The HVAC School podcast is made possible by these brand partners. NAVAC and NAVACglobal.com and the NAVAC NX1 Nexus Digital Manifold Gauge. It's got a great clear display, USB-C charging, and among the highest accuracy manifold gauges in the industry. To find out more, go to hvacrschool.com/NX1. Carrier and Carrier.com. I've been a Carrier dealer for many years. Carrier has their new GreenSpeed Extreme super high efficiency heat pumps out on the market now. Find out more by going to Carrier.com. Refrigeration Technologies, and specifically Viper Wipes, the all-purpose wipe that is really amazing what it can cut through. Everything from mastic to oil, grease, tar, grime, and it's nice on the hands. Makes them nice and soft when you're done. So that way you can go home and head out a-dancing when you get back to the house. Find out more at refrigetech.com/viper-wipes. refrigetech.com/viper-wipes. Copeland and Copeland.com. Copeland's site has white papers about regional adaptations to see how CO2 refrigeration is taking shape in your market. Learn about transcritical booster systems. Learn about different CO2 system types, including secondary and hybrid systems, with easy-to-understand explanations and system diagrams. Infographics, video series, webinars, and articles are all available on Copeland's site at copeland.com.
He's here to drink polar sparkling water and drop some wicked AC knowledge. And he's flat out of Polar. Bryan Orr.
Yes, sir. Yes, sirree. This is the HVAC School podcast. I'm Bryan, and this is the podcast that helps you remember some things that you might have forgotten along the way, as well as helps you remember some things that you forgot to know in the first place. And today I'm talking with Bert, and we're talking about one of his favorite conversations about leak detection and what are some of the things that you need to deploy your senses, those Spidey senses that you develop as a senior technician, which is really just becoming a master of the obvious, as Jim Bergman says. We need to become masters of the obvious before we can move on to using our super awesome ninja skills of using meters and gauges and all that stuff. And that's what we talk about today. What are some of the ways that we use your senses in leak detection and in noticing what the issue is in the first place relating to low refrigerant charge before you dive in and go any further? So here we go. Bert and I talking about refrigerant leak Spidey senses. Hey, Bert.
Hey, Bryan.
I kind of did that like Sesame Street. Hey, Bert. Hey. So Spidey Sense series, I started it off as short episodes, and then I realized that I was bored. Also, it's worth mentioning that talking about Spidey senses as part of the trade, I don't think I mentioned this last time, but that's definitely a Gary McCready thing. So props to Gary, because everybody knows Spidey Sense from the ubiquitous Marvel character Thor.
I actually had the nickname Spider-Man for a long time in this company.
Oh, from who? Did you give that name to yourself?
Man. I might have set it up a little bit. Dang it. Who was it? I don't remember who started it, but we had knocked over a ladder on a Winn-Dixie roof, and I crawled down a gutter and got the nickname Spider-Man.
Okay. All right. Yeah. So anyway, but just paying homage to Gary, HVAC Know-It-All. He does talk a lot about Spidey senses in the trades a lot. But what we're talking about specifically is going in and using your senses to notice things that can point you in the right direction, or it can give you some indication before you even start doing measurements. And that's, again, I'm a huge fan of measurement. I'm not saying that you don't need to prove that what you're saying is what it is, but in a lot of cases, you can end up being pointed in the right direction by following your senses.
It's the most basic tool that we have, but it's senior level stuff.
Heck yeah. So let's talk about it. So the first one we're going to do is leak detection, which is one of your favorites, but more specifically finding leaks, and more specifically than that, finding refrigerant leaks. So let's first talk about, to even know that you potentially have a refrigerant leak, what are some senior tech level Spidey sense things that you do that you're looking for in terms of refrigerant leaks?
When I'm actually chasing a leak, or just initially, am I even low?
That's what I'm saying. Hey, might have a leak here.
One thing is you walk up and the equipment's older. And so there's always that thing in your head, like stuff breaks down, evaporator starts to leak as it gets older. And then your suction line is warm. The system's running and the suction line's warm. And so immediately you're suspicious. Perhaps this is low in refrigerant.
Or in our market, your suction line is frosted up. See, this is where it gets tricky. Because I had a guy, you're making a weird face.
Yeah, I'm looking at you like, are you crazy?
I had a guy tell me that systems never freeze up because they're low.
Oh, okay. So if your system is low in refrigerant, you're not going to have frosted up ice on your external lines. You will have some ice build up if it's ran long enough on the indoor coil, but it's not going to be enough to bring ice out outside the unit where you see it build up on the line.
Yes, it will.
Okay, so no.
Yeah, you mean to tell me that you've absolutely never found a system that has ice outside because of it being low on charge?
I would say that the reason it had ice outside is because it was also experiencing a major airflow restriction. And sure, if it was a piston unit, I could just throw more refrigerant in it and that would solve it and I could walk away. So you can solve it by adding more refrigerant. But I would say that if the only issue is you're low on refrigerant, you're never going to find ice.
You will find frost outside sometimes in this market.
You say frost, but especially not frost.
All right, fine. Especially not frost?
That's right.
Really? Okay.
If you find it, it's going to be ice.
Oh. You're just being obstinate now. In my experience.
Okay. Back in the piston days.
Well, and actually, you probably and that probably is why, honestly.
That's only when you see it.
It really is why. Okay, yeah, this does. Yes, when I was doing more service, there was a lot of pistons. In fact, it was probably more systems had pistons than TXVs. And when you have a piston, you don't have that throttling effect. And so when in a TXV, when you get a frozen coil or frost in the coil, that TXV starts throttling really quickly. And so if you already are low on charge, and now the TXV is even throttling more because of ice buildup, frost buildup, then that's really going to reduce the amount of frosting that you get, that effect. So good point. I did have this guy argue with me. He was a guest really early on, and I don't even remember his name, but basically argued that it wasn't Jim Bergman. He argued that does not happen, but he was in Colorado. And when you're in a market where you do not have as much moisture in the air, you're not going to get as much icing because of low charge. To answer the question, though, most real freezing issues are due to airflow in some way. So that's just being clear here. But you will see ice sometimes because it's low on charge. And because what happens is it starts on the coil, on the first part of the coil. And then as that frost builds up, it just blocks the coil and creates an airflow problem. So in that case, what's happening is a low on charge issue is creating an airflow problem, which then exacerbates itself. And again,
you can find
TXV,
it. The combinations
throttle back.
All have to be right.
Well, I'm glad we established that. So
that was important.
But I think it was important. I think that was a perfectly good thing to discuss. We're talking about leak detection, so that went far afield. But that was, okay, so warm suction line. Here's something I would add. When you walk up to a system, one of the first things I always want techs doing is just watching for oil, and especially at the service valves. If you see a sign of oil at the service valves, at the ports, at the caps, anything, then do not take them off and connect. Get your bubbles out and check for leaks. First and foremost, even before you know anything. Maybe the system's been off, so you can't really tell, whatever. Just check there first, because a lot of times you're going to immediately find, oh, okay, well, it's bubbling around the cap. Cap doesn't have a seal. Schrader's leaking a little bit. All right. Now I know for a fact that that's an issue.
Yeah.
But what drives me nuts is guys will pull the cap off and they'll be like, oh, that Schrader's hissing. That's the reason it's low. It's like, well, not necessarily. If that seal is good on the cap, then that prevented that. And so you're going to attribute it being low to that leak when that is having a leaking Schrader, or as you always call it in all of your videos, a straighter.
You ever seen a crooked Schrader?
Yes, I have. When they're damaged. So anyway, oil is a biggie, and oil on the caps, all that, use soap bubbles beforehand. That's huge.
Yeah.
So now let's say that you connect to the system, you didn't see anything obvious, and now you have the system's low. That would be, like you said, warm suction line, high superheat, low zero subcool, low suction, low head. Typical stuff that you see when a system's low. And let's say that the system is it's not flat. It's not like at vapor pressure. The thing is still got liquid refrigerant in it. It's creating some cooling, but it's just not. It's definitely low on charge. What do you do next? Where does Spidey Sense play in now?
Initially, the Spidey Sense really kicks in if it's significantly low. So the fact that it's not super low, and this is a scenario you're giving me, then I know I could have a very detailed leak detection ahead of me. I'm probably going to need my electronic leak detector eventually, but you never start there, not if you're a Spidey Sense guy. So Spidey Sense tells me to open up the inside unit and check the condition of the evaporator coil and to start using my eyes.
What do your eyes tell you?
Well, I'll tell you what my eyes tell me.
Tell me.
My eyes are going to look over this coil for corrosion. My eyes are going to look in the pan for oil, water separation.
Do you actually see that regularly?
Mm-hmm.
Because that's the thing you mentioned, and I don't.
In the bottom of the pan. If there's been a long leak, not a quick one, but a long leak, there's oil separation in the bottom of the pan. And sometimes you can actually see the discoloration of the oil floating if there's water standing there. And so I'm looking for any spots that you can actually see an oil mark, a slight discoloration of metal, of copper. Copper's just too easy to find that leak. And then Mr. Spidey Sense, which is my new nickname for this podcast, is never going to be satisfied with the first leak that he finds.
Yeah. One of the things that I would add there is I'm looking at any common leak location. So you talked about the evaporator coil, but
even on the coil.
On the coil, yeah. But one thing that I want to be clear about, well, let me be clear. That was my Barack Obama impersonation. It's not great. Galvanic corrosion, so the steel plating rusting, is not really an indication of copper leaking. That's the thing that a lot of people get confused. Like, oh, look how rusty that is. The actual part that carries the refrigerant ain't made of steel. So rust isn't really an indication of a leak.
It's not an indication of where the leak is. It might be an indication of wear and tear on your coil.
It could be. And it can be an indication, especially of a more corrosive environment. And I think that's definitely true. And that's something we're learning a lot about is formic corrosion. Chemicals that are landing and living on that coil are really a huge factor in terms of leak potential. So anyway, but look at that. Look for corrosion, look at condition, but don't get too fixated on steel that's rusted. Look at things like you said, you get that blacking on copper, that sign of that actual copper corrosion. And then also look at wherever the tubes are crossing each other. That's a thing that really ticks me off when people miss that. Where it's like they condemn a coil and it was in a feeder tube and they could have fixed it and they didn't because they just put their leak detector there and they're like, oh, yeah, it's going off. That's how people sound when they say that. They go,
it's true.
Oh, yeah, it's going off. Look through places that are potentially rubbing and you can easily move things apart. Now, you don't want to create a leak where there wasn't one. That's the one thing I want to be careful about here is like you don't want to get violent with the thing. But if you see, and often you will see that blackening in between where the tubes touch, and then you pull them apart, and then sure enough, you see where it's been wearing down. Even if you don't find a leak there, you may find an area where it is rubbing, and that would be a place to put some foam tape or something to separate it out and keep that from becoming a worse problem. But that's one area. The other is anywhere like at the bottom of an accumulator, for example. Look underneath and see. You can grab a mirror and do that. But also if there's any dirt down in the bottom of the system or it's been like in our market, you get some places where the water gets pretty high a lot and that tends to corrode it out more quickly. Obviously, if you're in a salt air environment, all bets are off. Anything made of steel is a potential concern. So accumulators, even compressors at times, but line dryers as well are another big one, especially line dryers that have been buried and halfway in the dirt, which is why I always say, put your line dryers inside if you can. It's just common sense. That's what I always say.
That's really good is that even as you get more experience, even specific types of equipment, you have those repeat leak areas and you go looking for them. But before you're breaking out a tool and you're just starting to scan over everything, you should be looking at all your common points. And another one is any place that a human has interacted with the system. Like where are a human, a install technician or a service technician has interacted? Where are the braze joints? What are the things that have been put together with wrenches? Where's our flare connections?
Yes, flares are big.
Yeah. And so actually looking at the common points is going to say, usually it's 10 minutes, like a majority of systems, a little 10-minute inspection. You know exactly where you need to bust out your leak detector and do the confirmation. Like it's here. Let me grab my bubbles. Let me grab the leak detector. It's here.
Yeah, you make another good point. Anything that's a flare is always a red flag. Like, okay, we need to pay special attention to that. But also, like if you have a field installed expansion valve, you have some brands, especially in furnaces, where you're doing field expansion valves outside the coil. That's a red flag. Pay attention there. A lot of people will do the whole thing. We're like, if it's leaking now, it's always been leaking at a connection like that. It's like not actually always true.
Not even a brace connection.
Yeah, like there you have vibration, you have thermal changes, hot, cold. You have sometimes seismic events, or people are like, oh, that's California. Well, where I live, they have a mine that blasts like multiple times a day, some seasons, and that has an effect over time. And so leaks can appear even when there weren't leaks previously. And so any sort of field assembled connection you want to pay especially close attention to. And again, the idea that you're always going to see oil is also not necessarily true. There are some cases where leaks are so small that only refrigerant's leaking out, not necessarily oil making it as well.
If they're on the vapor line, I mean, that's
less likely.
Yeah.
For sure. And like, for example, you have a leak down on the bottom of a suction line outside where oil is going to tend to sit, where you're going to see more oil there. If you have a leak on the top of a large suction line up at the air handler, it's going to be less likely to carry as much oil out with that leak. So it does make a difference. Hey, HVAC School Podcast listeners. I wanted to read it like a normal ad. Hope you guys don't get tired of my ads, but this is a good one. This is a really good one. Don't skip this one. It's a good product. You're going to like it. It is the Wet Rag Heat Shield by Viper Refrigeration Technologies. Refrigeration Technologies is the company, Viper is the brand, and this flame-resistant pad is a game changer when it comes to preventing issues, damage, fires, stuff like that, as well as protecting sensitive components from heat transfer damage during your HVAC projects. The Wet Rag Heat Shield is made from high-temperature, fire-resistant, absorbent carbon. The absorbent part is key. You can use it wet or dry. With a woven core of fiberglass, making it versatile for both wet and dry use, like I just said. It's perfect for shielding wood, insulation, studs, walls, flooring, valves, painted surfaces, metal pipes, and other components or surfaces from heat damage. Plus, it's reusable, machine washable, and safe to dry. With resistance to up to 2,500 degrees Fahrenheit, you can trust the Wet Rag Heat Shield to protect your work environment and materials. We can't recommend this product enough. In fact, we did a video on it. If you go to their page, you'll find the video Bert did. It's a good one. It's been a lifesaver for us, and we know you'll love it too. Find the Wet Rag Heat Shield at a quality distributor near you, or go to TrueTechTools.com and make sure to use the offer code GetSchooled at checkout for an awesome discount. Trust us, this is an essential addition to your HVAC toolkit. Find out more, go to refrigetech.com/wetrag-heat shield. refrigetech.com/wetrag-heat shield. Nowadays, we also see more weird common leaks, like the issues that we've seen with ductless line sets. And that's another thing we're just knowing, like, oh, this is this brand of copper. This is one that we've been dealing with, and it actually just splits.
Experience stuff.
Yeah, and that's, I mean, that's Spidey Sense. Like paying attention, like, oh, that's that white insulation copper that tends to have this issue. And now you pull it back and you find those problems. Another one with leaks that I always want people to pay attention to is any sort of water softening equipment. One of my favorite things is when I was very young. Why did I say one of my favorite things? One of my favorite interactions with a client when I was a young tech, when I was working at a different company, is we had this case where they kept getting leaks, or they had a leak that they were trying to chase for a long time. And we were like, evaporator coil, all this. And then I finally noticed that the water softener was dumping right next to the condenser where the line sets come up. And in Florida, we run copper underground. Everybody freaks out about that. It's not the best idea, but that is just how it is done in the majority of houses in our market. And so the salt discharge was dumping there. And so I dug it up, and sure enough, copper was all greened, and that's where the leak was. And a client comes out and says, I'm a engineer of some sort, and I'll tell you right now that salt does not corrode copper. And it was one time when I was feeling especially snorkeling, I was like, okay, well, take a look at that. What do you call that? Which probably wasn't great.
Yeah.
But that's one. And then the other is looking at where the drains drain. Because a lot of times people will pour stuff down their drains, whether it's chlorine or even because we'll suggest vinegar, and even vinegar in high enough concentrations. You have somebody who's just being a real crazy with it, or they're using Drano or something else, and that dumps straight on the copper over time. That can cause corrosion as well.
I think an important part is to ask, what is the story? Like, what's the story behind this leak? Because, or even beforehand, when you're still looking out, you're not just looking for a leak, you're looking for a leak cause. And that can sometimes help you. And so like you mentioned before, do I have stuff rubbing together? But then also, how's this going into the house? Maybe I'm going up through a soffit and I know that copper is bent tight over the edge of the concrete roof there. Or you can visually just see this is wrapping around this tightly. So looking for the story of what caused this leak can often help you find it. Another thing too is sometimes you find that leak, maybe you find a split on a discharge line in your condenser. Why did this happen? You might repair it, get everything up and running, and then find out your condenser fan motors failed. You showed up to a flat system, and you also have something that caused that.
Yeah. Even probably just as common, or maybe even more common, is there's an issue with the compressor itself, where the compressor suspension is not like one of the springs is damaged or something.
Mm-hmm.
And
the vibration.
And so now the thing's vibrating like crazy. So that's another one. You especially see that in commercial, where if you've got some really weird, like something snapped off, especially, Like, hey, the discharge line's disconnected. Odds are you're not going to just reconnect that and it's going to be good. That happened for a reason. It's like seeing a turtle on a fence post.
That's what it's like, huh?
Yeah, because you see a turtle on a fence post, you sure as heck know he didn't get there by himself.
Yeah, that's true.
What you want to do is you don't just pull the turtle off. You look for the turtle
placer.
Turtle placing son of a gun who keeps doing this. It's a thing. It's a real problem. We used to cow tip when we were kids. Nowadays, they're always turtle placing.
It's like with the flare nut. You don't just tighten it down until the bubbles stop. And then you're like, okay, it's good.
You don't?
It's fine.
Oh.
No.
Because usually it was a poorly made flare is what you're saying.
It could be cracked or it's a poorly made flare. And then a couple weeks of vibration, what you just tightened down comes loose again.
And that's also why, because there's things that people will say, and I'm sure I've said it too, because there's the different little Teflon gaskets you can use for underneath flares to keep them from leaking, or people Nylog. A lot of people criticize me for talking about Nylog or using Nylog. And they'll say, that's taking the skill out of the trade.
Yeah.
That's not really the issue. It's more just it's always a yes and. So if you're going to do something like that, you're going to deploy one of those gaskets or something like that as part of your team. That's not a replacement for knowing how to make a proper flare. Because if you don't know how to make a proper flare, you can still make a flare bad enough that even that's not going to work. It's kind of like when Nathan used needle nose pliers to make a swedge the one time. Not the best practice. It was impressive, but I was like, I don't really think that that's how you should do that. In his defense, I think he was like 12 or something. So he's learned a lot since then. I'm sure he was. The next thing that I want to mention is just paying attention to changes in the house itself. So if a house has just been through a remodel or they just put a new roof on, that greatly increases the odds that the reason why it's flat or low is because of some change in the structure, especially if you're running copper overhead. We've run into this before. Copper gets run overhead and then they put a new roof on and somebody runs a nail through the copper tubing. Now, again, should you have proper strike plates in place to prevent that from happening? Sure, but it's just one of those things that does happen. So the more construction that's going on or things like that are changing, it's good to pay attention to that and potentially ask those questions at times. I mean, that's true of a lot of different problems, but leaks are definitely one. We kind of went out because I started off with a system's only slightly low. And then I went into this whole diatribe about all this other stuff that obviously would just be completely flat. But that is something to pay attention to. How low is it?
Yeah.
Because that's definitely going to direct you.
Yeah. There's nothing tickles the Spidey sense like getting a call from a junior tech and them being like, I got a couple hits on the evaporator, but I'm not really sure. And how low was it? It was about 7 pounds low. And you're like, yeah, you're going to have a massive leak. You're going to find it. Your leak detector will yell at you, or you're going to hear this leak. You can't just quote that evaporator coil and walk
Which
away.
Then makes you want to ask the question, why did you just put 7 pounds of refrigerant in this system, you big silly boy?
No, actually, we should probably talk about this. It is important to be able to estimate how low your system is for leak detection, because you kind of want to know, did this happen since the last maintenance? Did this happen yesterday? My system's flat. Or potentially they have that old coil that this is a vacation home and somebody hasn't been here for a while. And this could be a year-old leak. I'm a couple pounds low and you just have this tiny trickle. That can really help you with finding that leak.
You said a tiny trickle. That's just a funny way to describe a small refrigerant leak. I don't know if you know this, but when refrigerant comes out, it comes out as a gas. It's a really good point, though. And one thing, and this is more of a junior tech thing, like a really new tech. But if you walk up to a system and the pressure is low and the system's off, this comes,
Spidey Sense.
I got 30 PSI. What's your pressure? Well, 30 PSI, but it ain't running. Then you don't have a drop of liquid in that system, meaning that you are essentially the full system charge. Do not just start putting refrigerant in that thing. In fact, at that point, your best bet is probably going to go, it's just going to be use nitrogen and get the pressure up so that
nitrogen,
you can hear.
Use your ears.
Correct, at that point. Now, again, I know I probably went against technical EPA, but you are able to use a trace gas. And if it's really that low where you essentially have no refrigerant in the system, it's not going to be worth you pulling a recovery tank out. Just put the nitrogen in, get the pressure up.
Because you're also probably going to be putting some refrigerant back in if you can't hear that leak. So
correct. And that's the whole point. If you left refrigerant in it and you're putting nitrogen on top of it, then you will be able to find it with a leak detector because you're still going to have refrigerant molecules in there. Anyway, I know that what I just said does technically go against the EPA rules, but is such a practical practice that doesn't hurt anybody and is directly within the spirit that I even feel comfortable saying it publicly. Again, that's not the same as putting it on top of a system that's still got a pound of refrigerant in it. That's not what I'm talking about. I'm talking about a system that is, you go up to it, you hook up, and you've got 20 PSI. You have no refrigerant left in it.
We just call that
other than
flat.
just a trace amount. It's flat. The thing is not Nobody pulls out a recovery machine at that point. And so going to nitrogen is a much better bet than putting refrigerant in on top.
Mm-hmm.
And now you're going to waste all that as well. So be smart about that.
Anytime that standing pressures is below the saturation you would expect at that temperature, it's already a very significant leak. That means you already are dealing with almost no refrigerant in your system.
Correct. And being able to know that difference is super important, because you don't want the next impulse. This is, again, Spidey Sense, the next impulse to just put refrigerant in. It doesn't even make sense anyway, because the client has to pay for that. And so the guys who do that, they often are really screwing their employers as well, because that refrigerant is not cheap. And so if you had that conversation with the client, then you're screwing the client. If you didn't have that conversation with the client, then you're screwing your employer, because you've got to try to figure out where that leak is first. And that's where using your Spidey senses come in really handy, and where nitrogen is your friend. So let's next talk about bubbles. Like, when do you utilize bubbles and how do you do it?
Okay. Well, it's interesting.
It is interesting, which is why I asked.
This is one that people might disagree with me on, but I pull out bubbles when I pretty much know for sure that my leak is in a certain area. And I'm actually hesitant to start just spraying bubbles on stuff before my electronic leak detection, because I've had a wide range of leak detectors, and some of them sensitive enough to go off on whatever bubbles I'm using. And so I think that best practice, if it's obvious, get your bubbles out. There's no better way to prove a leak than to see bubbles. There's just no better way. If it's not obvious, take out the electronic leak detector and don't add more liquid, more things into the mix for you to try to pinpoint this leak.
To navigate, right?
To navigate.
Even if it's not an issue of your leak detector reacting to it. I'm just imagining John Pastorello right now hearing this and saying, like, well, you guys use Big Blue, right, Bert?
Yeah,
we use
do.
Big Blue.
Mm-hmm.
And he is going to tell you that there ain't no leak detector made that's going to react to Big Blue. So I'm just telling you. So even if that's not the case.
It is the case.
Even if it's not the case, you don't want to be putting your electronic leak detector into bubbles anyway.
Right.
Because you don't want to be sucking that stuff up in there. You don't want to get in the way. It's more that you have to clean up. So you really use bubbles once you already have a pretty good idea where it is. And so now you're like, okay, it's in this part of the coil. Let's see if I can find exactly where it is.
And you don't want to use a half gallon of bubbles just trying to find a leak because you don't trust your leak detector, or you're nervous, or you don't have experience there, or whatever it is, whatever the excuse is.
All right, let's pause for just a second and talk about NAVAC and the NAVAC NX1 Nexus digital manifold gauge. This sucker, you pull it out of the case. It's got a nice case, and you can just feel this thing is heavy duty. It's made to last. First thing I noticed was it charges with a USB-C, which is your standard Android charger, so you can charge it in the van really easily, which I like. The thing really holds a charge nicely. You don't have to keep finding batteries all the time, worrying about opening the battery door, which is always a pain in the butt on these things. It integrates with the NAVAC temperature probes and the NAVAC premium micron gauge. If you have not checked out these temperature probes and this micron gauge, you're going to love them. The micron gauge has the really high pressure rating, so it's okay if you do release the charge onto the micron gauge, which is nice. It's really small. It's very accurate. It connects with the My NAVAC app. But as much as I like the vacuum gauge, I love the temperature probes even more. The temperature probes, they use a high accuracy thermistor in them, and they have the temperature display right on the clamp. So it's super nice if you're just using it to take a quick superheat and subcool, or just to do like maybe a non-invasive test. You can still use these temperature probes. You don't have to connect them to an app to see the temperature. Really, really like that. It's got a great foldable heavy-duty hook on it, so the hook's not going to be an issue, and it's among the most accurate gauge in the industry. Also works with 72 different refrigerants, including both of the common A2Ls that we're seeing on the AC side, R32 and R454B. And of course, it's definitely A2L compatible. Find out more, go to hvacrschool.com/NX1. And as always, navacglobal.com. The only time that I would disagree with what you just said for sure is in the case that I talked about, when you see oil. And so you're trying to check for that, and also flare fittings at the condenser. And the reason is because flare fittings at the condenser are so likely because you just put gauges on. And so now there's this refrigerant, and even your gauge, your hoses and stuff, like trying to do an electronic leak detection in that area is like a fool's errand, because you're always going to pick up something. It reminds me of, there's this guy named Charlie back in the day. It's not any Charlie anybody knows, okay? His name doesn't work at Kalos, is old. And I don't know why I said his name. Why did I have to say his name? That was rude.
Charlie would love to know. He's a central part of this story.
He probably would. And Charlie would find condenser coil leaks all the time with his electronic leak detection. And he wasn't being dishonest. He was an honest guy. He was a good dude.
Yeah.
But Charlie just followed the practice. And we had some leaders who didn't really know air conditioning and weren't techs. And they would say, like, when you do a leak detection, leak detect everything. Because you want to make sure that it's not, they wanted to basically blame you for saying it was an evap when there was another leak. And so they'd say, do a leak to go over every single bit of the coil, go over every single, and any of us who are experienced know you don't do that. That's not what you do. You look at collection points for refrigerant, because refrigerant's heavier than air. That's where you start, and then you work your way up. But if there's no signs of oil, you don't just get random leaks in the middle of a condenser coil. That's not what happens. It could be maybe where it rubs out at the bottom or something like that. Charlie would find them in the middle of the coil. In fact, sometimes he would even just use like a red marker that he had, and he'd be like, it's right here, and he'd circle it. And what was happening is just in the process of connecting and disconnecting your gauges, refrigerant's all in there. And so you get a breeze and it blows up and it goes off. It's like, oh, there it is. And my leak detector went off.
And you can also have your leak detector just go off from a breeze or moving it too fast.
Some leak detectors will do that.
100%.
Yes.
You want to get your leak detector to go off, blow into it.
Well, that's your breath. That's a you thing specifically.
Clog it with your finger so it can't suck up air. And the sudden change, you'll watch. You do have to actually.
Again, it depends on the type of leak detector. You keep acting like you're used to using heated diode leak detectors, and that is, you get that.
It does, it does depend on the type, but yeah.
All that to say that just saying that you're going to do it everywhere is silly, but then also, because like, again, do you do every inch of every line set every time? Of course not. You have to use your senses. But the next thing is when you're at a flare fitting near the condenser, it's just very hard. It's like right there where the ports are and everything else.
Yeah.
So that's where, especially if I'm suspecting it, it's like, it's a flare connection on a ductless. And I'm often going to go straight to bubbles on that, just that spot. Because if it's in the inside, well, then that doesn't count. Because now if you're picking it up there at the flares with your electronic, well, then that's your primary indication.
Yeah. I don't want to hear that you found a leak within 6 or 12 inches of the service ports and you didn't prove it with bubbles.
Correct. And again, like the goal is to prove it every time with bubbles if you can. But let's also be realistic, because guys will say this, well, I got it in the evaporator coil. Well, did you prove it with bubbles? Well, sometimes you can, but if it's literally in the coil pack, you are not going to be able to prove that with bubbles in most cases. And you're not going to pull the fins off on a coil that's in somebody's house to prove that that's exactly where it is. That's not going to happen.
And situational awareness there too. Like, for instance, my system's less than a year old, and I'm getting a bunch of hits around this evaporator coil. I can't really pinpoint the exact spot. There's just so much refrigerant everywhere. I'm going to quote the coil. No, it's one of your brace joints, or it's your line set. It's something nearby.
Yeah. Or you put in a field installed expansion valve and it's where the external equalizer connects. Or it's a case where one wasn't put in and the cap for the external equalizer is leaking. Or like, there's just all that doofy stuff. It's just pay attention. If it's newer, it's more likely to be related to field installed. If it's older, it's more likely to be due to corrosion. But that isn't always true. Like we mentioned, you will get field connections that didn't leak for years and now are leaking. And again, contributing factors to that. System vibrating more, compressors not doing so great, whatever. Pay attention to that.
When is a good time to go to the isolation test?
That is very company specific. And for us, we go to the isolation test, again, buried copper. So obviously, if you can physically get to your line set, then an isolation test isn't necessary. If you're in a basement and like you can see the whole thing, well, why would you do an isolation test? You can literally get to the entire line set. But when you can't, and it makes sense, like, we just did a change out and we didn't really do a good job of confirming we reused the old copper. And it seems pretty likely that increases the odds that you would do that. And it's once you've exhausted all the other possibilities. And it seems, and you basically, what I say about doing an isolation test is you do that when you essentially already know that it's in the line.
That's right.
Guys who will do it, I talked to somebody recently and they're like, hey, we want to do it every time because we want to prove if it's in the line set, if it's in the condenser, if it's in the evaporator coil. It's like, come on.
And the amount of times you do it and you don't have a leak at the end of that story, if that's your process, it's going to be very frustrating for your customer.
Yeah, because we have probably arguably the worst possible market for copper leaks, meaning that we've got a lot of coastal markets and we're running it underground. So there's more likely that stuff's going to attack it, whatever. And it is so rare to have copper that doesn't, if it leaks for a reason. And it's usually a reason that you can figure out. It's like the facility's using reclaimed water, and so they're using higher concentrations of chlorine in that reclaimed water or some other chemical. And so that's attacking the copper under the ground, something like that. It's not like, oh, hey, there's just this copper in a wall and it's just leaking, unless it's the particular brands of copper that had that issue with ductless pre-insulated line sets. So it's using common sense and not being, I don't know what drives me more crazy. The sloppy young tech who isn't thorough, or the old tech who acts like you have to go through these exotic and unrealistic processes every single time. That's a good example of that. I do a line isolation every single time, and I put every evaporator coil in a water dunk before I leave the site so that I can see exactly where the bubbles. It's like, it's like fine if you're a one-man show and all of your clients are like billionaires or something, but it's not practical in most cases. So using a little common sense is pretty big. I did want you to just talk through quickly when you use soap bubbles. We've done this a lot. A lot of people use soap bubbles wrong. They just go spray crazy all over the place.
Yeah, that's very true. So first off, when you're applying the soap bubbles, you need to make sure that you're actually applying it without creating a bunch of bubbles and mess. It's easy to go crazy and spray bubbles all over the place, and then you've created your own mess of bubbles and foam, and good luck finding the actual hole. And so apply it on really smooth. Make sure that if there's a bubble there, that it's going to show up on its own. And so first of all, we're going to go with the extreme leaks. There are enough leaks that I've found with bubbles that when I put the bubble on and sprayed it all over this area that I could see oil, I had no bubbles. I couldn't find any leak. And it was because the leak was so fast, it actually broke the surface of the bubble before you could pick up on where it was. And if you're not looking and seeing that happen, so just pay attention to that. You got a really fast leak, and usually you're going to hear that. And you're trying to find it with bubbles, and you can hear it. It's somewhere. Just put the bubbles in your hand and start grabbing copper. That's about the best way.
Or just give your hand an old Hawk-Tuah and use that instead at that point. I mean, don't even... Sorry, I just had to say it. I mean, there's a time when...
If you haven't done that...
You're just lying is what you're doing right now.
That's right.
Yeah. And then the other side of the equation
The other side of the equation is when you have a really small leak, you get the micro bubble effect. And like with Big Blue, if you read the spray bottle on the back, there's instructions. You spray that on, come back and check in 2 to 5 minutes and see if you're starting to develop this micro trail of bubbles. And that's what it looks like. It looks like a tiny little river of small white foam coming out of this leak. And honestly, a leak that size, you're not going to pick up on a 30-minute isolation test. And that's why, like, when you're installing new equipment or doing a major repair, you use bubbles on all of your joints. You don't just rely on your leak pressure test, because something that small, your bubbles can pick up and they can show off. And it might take 24 hours to pick it up with a pressure
And
test.
that's the thing. Everything that we do on and we're not talking about like pressure test here, but they all have their own role. And there are leaks that are so small that will leak down over time and be a problem for the system, that you still passed your decay test.
Yeah.
You passed your pressure test. You did all that because it's just a tiny, tiny, tiny leak. And again, it depends on what the internal volume of the system is. So the more internal volume that you have on the system, you get a big 4 or 5 ton unit with a long line set and 7/8 or inch and 1/8 suction line.
You're not going to hear from that client for a long time.
It's going to be a while. And also, it's just because there's so much internal volume, that vacuum and the pressure test, there's a lot of molecules contained. And so it just doesn't show up. You don't see these big swings like you would expect. And that's where a lot of techs believe that if they do those two things right, that you'll never have a leak. But again, anytime you're field fabricating flares, chat lift connections, any threaded connection, and anytime you're brazing, use bubbles during your pressure test. And do it just like Bert said. You put it on flat, and so it's like glass, and then you just leave it there. I'm bad at this. I've always historically, I've been pretty bad at this. But we have found a lot of leaks this way, and that is the best way to do it. Spray it on, just let it sit. Come back when you're towards the end of your pressure test and just
Bring
look.
a mirror.
Bring a mirror. Always got to have a mirror, have a flashlight.
Yeah, a really common mistake that I see is people they're checking the box with the bubbles at the end of their quoted repair. They spray it on and they kind of walk by and they're like, if it was leaking, I would see it or I'd hear it. And so no, do a really fine inspection on this.
Also worth noting, ultrasonic is a type of leak detection a lot of people like. Our good friend Craig, AC Service Tech. I didn't even try to say his last name because I never get it right. It doesn't matter how many times I just don't get it right. So he really advocates for ultrasonic because it allows you to hear things that you couldn't normally hear. And I have tried it and I'm not good at it. And that's just the only reason why. So those of you who want to take advantage of that technology, the advantage is that it works with both nitrogen and with refrigerant, which is handy. So
that makes sense.
Good. Anything else?
Probably, but that was pretty good.
No, it's good enough for Spidey Sense.
Yeah,
Thanks,
it is.
Bert.
Yeah, sure thing.
Big thanks to Bert. Big thanks to the whole Kalos team. We've got the symposium coming up, and a lot of people are frustrated because we have not announced where it's going to be yet. Now, I know it's still quite a few months away, but people want to make their plans, and I know we have it planned to be at the Lakeside Center in Ocoee, Florida. And that is 98.5% confirmed, but there's like this whole permit application process, and we couldn't apply until a certain time, and so really weren't able to know for sure. We want to have it here because I think it'll still kind of maintain that soul that we want for the symposium, where we can have a lot of it outside and all that kind of thing, as well as accommodate a lot more people, as well as be closer to AHR. So AHR is in Orlando this year, and we're just going to try to make it a real smooth transition right from the symposium to AHR. That's why we're only doing 2 days this year instead of 3, but we're going to have an amazing group of speakers, and we're going to have more vendors and more attendees than ever. So it's going to be an amazing time. Find out more, get your tickets by going to hvacrschool.com and go up to events and look at our 6th annual symposium 2025. Yeah, my parrot died today. He was a big boy. He really knew how to pack in the bird seed. It's sad news, but it's a huge weight off my shoulders. The way I told that joke made it just horrible, just awful. But hey, thanks for listening. We'll talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.